Welcome to another episode of Lineman Talk. Today we're going to work to answer the question, is cleaning the conductor really necessary before you make a connection? In this utility, everyone concerns himself with losses. That's the difference between the number of watts that we buy and the number of watts that we sell. We install capacitor banks. We do voltage conversions that reduce currents. We do thermal inspections to find hot joints. We do conductor changes so that we can put bigger wire. All of this is an effort to reduce losses. Recently I did a thermal inspection at a substation and I found a jumper that was hot at the connectors. Now, in the old days, we always felt that the hot joint was between the two mating surfaces. Since then, we've learned we'll, clean, polish, and then find that we still have the same hot joint. So we learned that sometimes it's the crimp, the way that we crimped it. We could blame the compression tool or the method, but most of our conductors that we use are aluminum, and aluminum oxidizes as soon as air touches it. So we have products like aluminum oxide paste that we'll use, and almost every connector that we buy has that oxide paste in the connector. Today we're going to use a Vanguard Auto Ohm 200 micro ohm meter, digital low resistance ohm meter, and we're going to test the jumper that I found. The crew removed that jumper, and we're going to find out the difference between one end to center and the other end to center, and measure that with a DLRO to get a baseline for what did we see and what was the micro ohm difference that allowed that current to produce the heat that I could see. So this is the jumper that they replaced. This is the type of connector that we use, compression on both ends. So the first thing we're going to do is we're going to cut the conductor that they pulled down in half, and then we'll use the DLRO to measure the micro ohm resistance from the cable back to the connector, and maybe we can learn if it was the mating surface or it was the crimp. So what we do in all of our videos, what comes first? Safety. So we have our hard hat as part of our uniforms, we have our eye protection, and we'll put on some leather work gloves. So now that we have our safety equipment on, we'll go ahead and get our battery powered cutter, and we'll cut this conductor in half. I've already predetermined the distance from one end to the other to find center. That way when we use our DLRO, we'll be measuring exactly the same amount of wire. And what I plan to do here is we'll put crimps on after we do our initial test. I'll put crimps on and we'll clean one of the conductors before we put the crimp on, and the other one we will not. And we'll see how important is cleaning the conductor, removing the oxide from the aluminum conductor. We have our connectors. Now we'll put the DLRO in the middle of the table and we'll be able to use it. You'll be able to see it. We'll energize it. What I do is I set the meter for 200 amps current and a 30-second burn-in. So we'll set that up and then we'll do the test and we'll have a number to work with. So this is leg 1. All right, that number is 75.2 micro ohms. Now we'll clear that cable and we'll do the second one. We have cable 2 set up. We're going to go ahead and do our test. We'll be using the exact same parameters as the other cable. This cable comes back at 52.6 microohms. Line crew might say, we're talking about 20 microohms. I make the parallel. If I had a 5-gallon bucket and I was filling it up with an eyedropper, one drop at a time wouldn't make much difference. But give me 1,000,000 drops, and now the 5-gallon bucket's full. This is the parallel. Each one of these connections is a loss. Now multiply that times 1,000,000 connectors. If I have 9,000 miles of overhead line, 200 or 300 miles of underground primary, several hundred miles of transmission line, every time we make a connection, we have an opportunity to create loss.